Hello, ArtSciTech viewers. Today, we're diving deep into a question that stretches the limits of imagination. What would happen if we could touch the center of the Earth with our finger? This isn't just a scientific curiosity, it's a philosophical and fantastical journey. Especially for those intrigued by Earth's internal structure and its mysterious core, this video will examine our planet's layers under a microscope. So if you're ready, let's embark on an epic adventure to the heart of our world. Presenting, touching the center of the Earth. Close your eyes for a moment and imagine this. You reach out your hand and touch the very core of the Earth, touching the planet's deepest secret with your fingertip. But what would this impossible touch mean? And if it was somehow possible, what would it feel like? To answer that, we first need to understand Earth's layered structure and the secrets of its core. Let's peel back the layers of this story one by one. Earth is like a cosmic onion, built in layers, each with its own unique properties. Let's break them down. Crust, the outermost layer we live on. It's thin, just 5 to 10 kilometers under oceans and 30 to 70 kilometers under continents. Made of granite and basalt, the crust makes up only 1% of Earth's total mass. It's brittle, cold, and home to tectonic plates. Mantle. Beneath the crust, the mantle extends down to about 2,900 kilometers. Making up 84% of Earth's volume, this hot, viscous silicate layer ranges from 1,000 degrees Celsius to 3,700 degrees Celsius. It behaves like a solid, but flows slowly over time, driving tectonic activity and volcanism. Outer core. Starting at 2,900 kilometers deep, the outer core is a sea of liquid metal, mainly iron and nickel. Temperatures here reach 4,000 to 5,000 degrees Celsius. This liquid motion powers the dynamo that generates Earth's magnetic field. Inner core. At the very center, 5,150 kilometers down, lies the solid inner core, a metal sphere roughly 1,220 kilometers in diameter, about 1/3 the size of the Moon. This is the spot we dream of touching. The inner core is the beating heart of our planet, composed mostly of iron, 80%, and nickel, 20%. It also contains traces of sulfur, oxygen, and silicon. Let's explore its mind-blowing traits. Temperature and pressure. At around 5,500 degrees Celsius to 6,000 degrees Celsius, the core rivals the surface of the Sun. But it's also under 3.6 million atmospheres of pressure, squeezing atoms into a dense, crystalline structure. The atoms barely move, only vibrate. Crystal structure. Scientists believe the iron crystals are arranged in either hexagonal or cubic patterns. Curiously, seismic waves travel at different speeds through the eastern and western hemispheres, suggesting asymmetry. Rotation speed. The inner core rotates slightly faster than the rest of the planet, a phenomenon called superrotation, a few degrees per year. This affects Earth's magnetic dynamics. Formation. The inner core began to solidify as Earth cooled. Originally, Earth was fully molten. Over billions of years, the metals at its center crystallized. The inner core still grows a few millimeters every century. Before we can imagine touching it, we must understand the sea of molten metal that surrounds it, the outer core. Surrounding the inner core is a 2,260 kilometer thick layer of molten iron and nickel. Here's what we know. Composition. Similar to the inner core, but with more lightweight elements like sulfur, oxygen, and carbon, making it less dense and keeping it liquid. Temperature and density. With temps between 4,000 degrees Celsius and 5,000 degrees Celsius and a density of 9.9 to 12.2 grams per cubic centimeter, this layer remains fluid despite the pressure. Source of magnetic field. Convection currents in the outer core, combined with Earth's rotation, generate our magnetic field, which shields us from solar wind and cosmic rays. Seismic clues. We know the outer core is liquid because shear waves, S waves, can't pass through it, while pressure waves, P waves, slow down, clear signs of fluid layer. So, how close have humans ever come to this mysterious core? The most ambitious effort to reach Earth's depths was the Kola Superdeep Borehole in Russia, begun in the 1970s. It reached 12,262 meters, just 0.2% of the way to the center. To reach the core, we need to go another 6,371 kilometers. The project was halted in 1992 due to extreme heat, over 350 degrees Celsius, and technical limitations. Even reaching the mantle remains impossible for now. But what if we removed all physical barriers? Let's imagine that all limits, heat, pressure, gravity, suddenly vanish. You reach out and touch the inner core. What would it feel like? It wouldn't be a smooth steel ball, but a dense, crystalline metal structure. You feel extreme hardness and density. But there's more than touch. How would the core's electric and magnetic forces affect the experience? Touching the inner core wouldn't feel like cold steel. Its density, 12.8 grams per cubic centimeter, would prevent your finger from sliding. You might sense micro-vibrations from the iron crystals, like a faint buzzing. And the core's rotation could add a strange dynamic feel. But the magnetic and electrical effects would be even more curious. Since the core plays a role in Earth's magnetic field, your touch could theoretically disturb the field, even if just locally. The metallic structure might deliver a tiny electrical shock. This interaction could trigger a brief magnetic ripple. Of course, this is purely speculative, but what if we looked at the touch metaphorically? To touch the Earth's heart is more than a science fantasy. It's a metaphor. It's about connecting with nature, the universe, and our inner selves. Touching the core could symbolize confronting our fears, dreams, and essence. It's a poetic fusion of science and imagination. How has science fiction tackled this idea? Jules Verne's journey to the center of the Earth sparked public imagination. The 2003 film, The Core, explored the idea of restarting the core with nuclear bombs, wildly unrealistic, but emotionally compelling. Such stories reflect our enduring curiosity about the unknown. But could reality ever catch up? With current technology, reaching the inner core is impossible. But one day, maybe, ultra-strong materials like graphene, plasma shields, or quantum tunneling might make it possible. High-pressure nanotech or energy barriers could open new doors. It might take centuries, but our curiosity will keep pushing deeper. Dear ArtSciTech viewers, touching Earth's center is more than a scientific question. It's a reflection of our imagination, curiosity, and our quest to understand our place in the cosmos. The inner core is the planet's heart, and its mysteries continue to inspire us. If you enjoyed this video, don't forget to subscribe to ArtSciTech and leave your thoughts in the comments. What do you think it would feel like to touch the Earth's core? What should we explore in our next episode? See you soon.